So the next color up here is orange. And orange, everybody calls Mars the red planet, but in fact it's really more of an orange color. I love the planet Mars, it's awesome. Look at this thing. Here's a whole planet, and this is a canyon going across it. This is a canyon system that would span North America. Any one of these tiny little canyons on the side, these little tributary canyons, any one of those are bigger than the Grand Canyon. This is Olympus Mons, a giant volcano, 3 times the height of Mount Everest. If we were on one side of it here in Hamilton, the other side would be where Ottawa is. It's absolutely massive. And here's the surface of the planet Mars, and you can see the sand is this orangey rusty color. And that's because it's oxidized. It really is that orangey color. This is a picture from the surface of Mars, but of course Mars has different atmosphere. Light passes through it differently, and as we said at the very beginning, when we talked about why the sun looks yellow, how light passes through the atmosphere determines the color of things here on the ground. And it happens there. If we rebalanced this photo and pretended that this was the Earth, the surface of Mars would look something like that. But it doesn't. It looks like the top one up there. This is, I think, the world's coolest selfie, all right? This is the Curiosity probe on the surface of Mars. This is a real picture, and it has a number of different cameras. One camera's on an arm, and it held the arm up, turned the camera back towards itself, and went click, 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 click. Took a whole bunch of pictures, and we patched them all together, and we got this. So here it is on the surface of Mars, and it drives around. You can see it's on wheels, all right? And it drives around. This is a camera assembly right here, and this is another one down here. And it drives around on the surface of Mars, examining rocks, and we've been learning all kinds of amazing stuff from it. And it's been sending back pictures like this, and this. And this one came back yesterday. This is a picture that was taken on the surface of Mars yesterday, all right? So it hasn't been processed for color, so it's just because it's still brand new. I think that's fantastic. And of course, you know, there's a nighttime view from the surface of Mars. But here's my question, right, to you. Remember what I said at the beginning? The sun looks yellow because the blue is scattered out of it. Well, on Mars, okay, the sky isn't blue. The sky has all of this sand and dust floating in it, all right? And that scatters the bigger wavelengths, red and orange. And so the sky has this kind of cool orangey color to it. And so when the sun sets, all right, on Mars, if we get red scattered, or if we get blue light scattered here, when the sun sets on Earth, the sun turns red. If the red light is scattered on Mars, when the sun sets, the sun turns blue. And this is sunset on Mars. It's a real photograph, okay, from the surface of Mars. And the sun turns blue. Now that actually happens here on Earth sometimes, and you have to get all that sand and dust and particulate matter suspended in the atmosphere. And that can happen if there's like a major volcanic eruption, or if there's forest fires like this. And that will turn the sky yellow, and that means it'll turn the sun bluish looking. Or, if you go out and look at the moon, it'll turn the moon the same color. Now this happens very, very rarely. It's unusual to see something like that, and that's where we get the expression, once in a blue moon. Next color up is green, and the first thing I thought I wanted to talk about when talking about green was comets, because I thought, oh, comets are super cool, because they're green in their heads because of cyanogen gas, and it's highly poisonous. And people used to think that if a comet went by, you could actually be poisoned by it. They used to sell gas masks and that. But I thought there was actually something cooler than that, and that's the northern lights. Remember our view of the sun here? And remember all of this gas shooting off? Well, that gas has charged particles in it. And those charged particles, they have an electrical charge, and they travel to the Earth, and they interact with the Earth's magnetic field, right? And those charged particles are funneled by the Earth's magnetic field towards the Earth's magnetic poles. And when they get there, they run into the Earth's atmosphere. And when they run into the Earth's atmosphere, something really cool happens. And you know what it is. You see it all the time. It's just like a neon light. A neon light is a tube with gas in it. You put electricity through it, and it energizes the gas. When the gas is energized, or when the gas returns to its normal state, from its energized state, it releases the energy in a very specific frequency of light. And the gas lights up. You see that frequency of light. Well, that's what happens in the sky, all right? These charged particles from the sun impart energy into the gas in our atmosphere. the gas in the atmosphere returns to its natural energy state by releasing that energy in the form of a very specific frequency of light. And that frequency of light is green. And that's what the northern lights are, all right? The northern lights are free-form neon lights, except it's not neon, it's oxygen and nitrogen in our atmosphere, but it basically works the same as free-form neon lights in our atmosphere, all right? So, and the most common color that you get to see, because that's the color they re-release the energy at, is green.